1981, a French physicist made light stand perfectly still. So why did France's science ministry fire him and seize his notebooks? He was Dr. Michel Armand, a young researcher at the Institut d'Optique in Orsay, a campus that smelled faintly of ozone and liquid nitrogen, where the air hummed with the low, steady whine of cooling systems and the occasional crackle of laser pulses. Michel had spent months polishing a sapphire crystal, shaping it into a flawless slab, then cooling it inside a cryostat to a temperature just a few millikelvins above absolute zero. The chamber glowed with a pale blue frost, and a thin laser beam sliced through the frozen crystal, its photons racing at their usual speed of 300,000 kilometers per second. Michel adjusted a magnetic coil, turned a dial, and watched the detector read a sudden pause. The beam stopped dead, as if an invisible wall had appeared. The data log showed a flat line for 20 seconds before the light resumed its march. The team gasped, then fell silent, the sound of their breathing the only thing that filled the room. A pause in light meant a break in Einstein's rule, a crack in the foundation of quantum communication that relied on photons traveling at a constant speed. The discovery could have turned secure encryption on its head, giving anyone who could halt photons a way to read secret messages. The lab chief, Professor Léon Marchand, called an emergency meeting. He whispered that the Ministry of Higher Education had already been briefed, his voice barely rising above the soft hum of the equipment. Within days, a sealed order arrived, stamped with the words "classified, 40 years." Michel was summoned to a plain, windowless office, handed a termination notice, and ordered to destroy his research notebook. He complied, but slipped a single page into a hidden envelope. The envelope vanished into a drawer that would later be emptied during a routine audit. For 40 years, the experiment lived only in that secret file, locked behind a steel door in a basement archive. In the late 2010s, a historian of science named Claire Dubois filed a request for declassification under a transparency law. The request cited the file number, a cryptic reference to photon stasis project. After a bureaucratic shuffle, the archive opened, and Claire pulled out a stack of yellowed papers, their edges frayed and the ink faint from decades of neglect. The first page was a handwritten note: "If light can be stopped, then time can be measured in a new way." The note was dated March 1981, exactly the day of the experiment. Claire read about the crystal's composition, a rare synthetic sapphire doped with erbium, and the magnetic field strength, 12 teslas, that had been applied. She saw the raw data, the spikes, the flat line, and the calculations that suggested the photons had entered a bound state, trapped by the crystal lattice. The report concluded that the effect was reproducible, but warned that scaling the technique could disrupt any system that relied on unimpeded light transmission. The ministry's response, written in a terse memorandum, argued that public release would undermine national security and invite hostile powers to exploit the technology. The memo also recommended that the lead researcher be removed to protect the integrity of the scientific community. Michel, now in his 60s, lived a quiet retirement, his reputation tarnished, his name omitted from citations. He never spoke of the experiment, fearing legal repercussions. When Claire called him for an interview, he hesitated, then agreed. He described the night of the pause, the lab lights flickering, the low hum of the cryocooler, the sudden silence when the detector stopped. He recalled the metallic taste of fear in his mouth, the weight of the sealed order, and the resolve to hide a single page. "I knew the world would not be ready," he said, voice trembling. But the truth cannot stay hidden forever. After the interview, Claire published an article in a peer-reviewed journal, anonymizing the scientist, but preserving the core facts. The paper sparked debate among physicists, who argued over the feasibility of stopping light without violating relativity. Some dismissed it as a measurement error. Others suggested that the crystal's exotic properties might indeed create a temporary photonic band gap. The controversy reignited interest in quantum memory research, and a new generation of labs began exploring ultra-cold crystals for photon storage. In 2023, a research team at the University of Cambridge announced they had achieved a similar pause using a different material, confirming that Michel's observation was not an isolated glitch. The French ministry finally lifted the classification, acknowledging that the original experiment had been a pioneer study with potential strategic implications. The Cambridge group, led by Dr. Aisha Patel, had spent years cooling a diamond-like carbon lattice to within a microkelvin of absolute zero. When their detectors finally recorded a brief cessation of photons, the lab erupted in a mixture of disbelief and exhilaration, the air thick with the smell of heated metal and the soft click of data servers storing the result. Their paper, published in Nature Physics, highlighted the ethical dilemma of releasing a technology that could render current fiber optic networks obsolete and called for an international dialogue on responsible photon control. Michel's notebook page, once hidden, now sits in a public archive. Its ink faded, but its message clear: science can challenge the limits we accept, and institutions will sometimes push back to preserve the status quo. The story shows how a single moment, a beam of light frozen in time, can ripple through decades, shaping policies, careers, and the direction of research. It also reminds us that hidden chapters of history can surface when curious minds keep asking, what really happened? Subscribe to see what else they tried to erase from the textbooks.